Okay, so this is problem 3.81 from the textbook. We have this cantilever bar, and they want us to find the critical stress, the critical stress element drawing, and principal stresses and max shear stress based off of this diagram. And Fy is 175, Fx is 0, and Fz is 100. So because f of x is 0, we're gonna be starting off by taking the moment of one of the other two. So I'll start with the moment of z, and that is going to be, in this case, around z we would have the force of Fy, and then that is going to be multiplied by the distance, which is going to turn into 175 lbf times 8, and then getting my calculator out. 175 times 8 is going to be 1400 lbf per inches. And then we are going to be taking the moment around y. And in that case, we are going to be taking, it's going to be a negative Fc and then times the distance, which will turn into the force of y, which up here, or the force of z, which up here is 100. So 100 lbf times 8, and that, or 100, 8, I don't know why I used a calculator for that, negative 800 lbf inches. So now that we have those two, we're going to be taking the resultant force of those, which in this case is going to be like mr, and we don't have the x, so it's really just going to be mz squared plus my squared. So that's going to be the 800 squared plus the 1400 squared. And that on my calculator is that's going to be 1,602.45 lbf inches. So that's going to be our resultant moment for this problem. So now that we have the magnitude of the resultant, we're going to find out the angle that this is going at. So the theta is going to equal the inverse tangent of my, which in this case is the 800, over mz, which is the 1400. And the negative tangent of that, 800 divided by, is, oops, radians. Negative tangent 800 divided by, that is going to come out to be 29.74 degrees approximately. So now we can find torque with our at A, which is also something that we're going to need. So at A, which I didn't label it on here, this is A right here. What we're going to need to do is the torque at A is going to be the force at Y times this length right here. And that's going to come out to be negative 875 lbf per inches. So now that we have kind of some pre-stuff done, that was basically A, and now we can move on to B. So for B, we're going to be finding, they want the critical stress element drawing and the locations of the critical stresses. So I guess we're not totally done with A, so I'll just keep going. So the bending stress at the cross section, the formula for that is 32 mr over pi d cubed. So we have our mr, so we're just going to plug it in. It's the 1612.45. We know our diameter is 1. It's not labeled on here, but my bad. And that's going to come out to be 16424.28 psi. So that's the bending stress. So this equals, there we go. And so now they want the torsional shear stress. So the equation for that is going to be negative 16t over pi d cubed. We found our torque up here, so that's what we're going to plug in for this. So this is going to turn into a positive pi and then our diameter of 1 again. And that's going to come out to be That's going to be 4.456 kpsi. We'll put it in, so, or 4,000, so yeah, normal psi. So now that we have the torsional shear stress, we want the transverse shear stress. So I guess I'll have to put torsional, and then this is the transverse. And so in this case, the formula that we normally use is the 4v over 3a. So that's going to turn into 175, 3 pi force, and then the diameter, or how we find the diameter here would be pi over force and then diameter squared. So I'm just going to put in the 1 squared there. And that will come out to be 297.1 psi. So there's that. Scooting up. And that's actually pretty small. Like this is in psi and that's kpsi. So I think we neglect that on our picture. So I think we're gonna neglect that on our picture because it was pretty small. So now we're gonna do our picture. I don't know, I'll do it right here. So draw our little box. And we're gonna have our, let's think about this. Okay, our cross-sectional is gonna go here. Yeah, and this is gonna be here. It's pulling this way, and then these two would meet here. So this is gonna be the torsional one. So that's the 4.456 kpsi. And then here, okay. And then right here is where our bending is gonna go. And that was the, yeah, we'll just put that in kpsi. And then this will come out here. So that's our picture for this part. And then I'll probably take this off. So now we're gonna show how the torsional stress actually occurs on the cross section. So if we draw a circle here, wow, this is not a bad circle. Okay, and then we know it's gonna kind of be up in this region here, and it would be kind of as our picture was showing, it would be pulling or like having the force act like that. So that's torsional stress. And then bending, it's gonna have, I'll do it right underneath. Bending is going to have like 4. And they'll all be going this way as well. So I won't draw all of them, but the arrows will all be going clockwise, like so. So that's due to the bending stress. So now they want us to find the principal stresses. So this is part C. So stress 1, the formula that we use is always the x, you know, plus or minus, and then x over 2 squared plus, the which one do we use? Oh yeah, we're gonna be using the torsional. That's what goes here. And that's going to be squared too. So that's going to turn into the 16.42 over 2 plus 16.42 over 2 squared plus 4.456 squared. And when we plus or minus that, it's going to be we're gonna get for stress 1, 8.21, and then plus, so that's the B, so 8.21 plus 9.34 is gonna turn into, so stress 1 is 17.55, and stress 2 is gonna be negative 1.13. So that's what we have there. So that's gonna be KPSI and KPSI. So those are gonna be our answers for that. And then to find the max, T max is gonna be equal to the X, or the bending, and then again the torsional. So basically just this portion of our equation. And so that's gonna be 16.42 squared over 2 plus 4.456. So we kind of already can tell that it's gonna be the 9.34, which it will come out to be because we already solved for that part. So that's the max. And that is question 3.81.